Hello guys, this is prime concept. Still, we are analyzing the concept of vector multiplication. We have introduced the different types of multiplication that we do in vectors. If you have not seen my previous video, just click my channel now, go to the playlist. You'll see vector analysis and check the playlist. You can understand vectors sequentially. So in this video, we want to consider another part of vector multiplication, which is what we know as vector product. So we call it vector or cross product. So it's another type. Remember, we mentioned that we have two classes. We talked about multiplication of two vectors, which is where we have our scalar product and our vector product. So in our previous video, we learned scalar product. In this video, we want to understand vector product. So do well to stick with me in this video till the end, and the concept will be revealed to you. Now, for vector product, we want to learn what it is. So vector product is actually the product of two vectors that gives rise to another vector, and that is why we call it vector product. So this kind of multiplication would give rise, or it would yield another vector. Remember, for vector analysis, how you know that you have a vector is if that quantity carries I, j, or k, means it is a vector, because I, j, and k represents the direction. So, but when you carry out a multiplication and your answer does not carry I, j, or k, means your answer is a scalar. So this type of product, it gives rise to a vector, or you can say another vector, and that is why we call it vector product. Now, why do we call it cross product? Is because the symbol for this multiplication is a cross, and that is why we call it cross product. Say we have A and B, then their cross product is going to be A cross B. So this is how we denote the cross product of vector product, and this is why we call it cross product, right? Very important. So now we want to quickly look at the two types of vector product. We have two types, but before we study that and the two types, there's something I want you to learn very quickly, which I'm going to also give as a point to note. So let's note this, which is very important. Remember, we're studying vectors in 3 dimensions. So in our 3-dimensional system, I can call this place my x-axis, and the unit vector that gives me this direction is I call here my y-axis. The unit vector that gives me this direction is j. I call here my z-axis. The unit vector here is k. Now, one of the things you want to know is that if I multiply in this way, see my arrow, we're going to follow arrow, because in vectors are usually denoted with arrowheads. So I have this. So if I multiply following or obeying the arrow direction, my result will be positive. But if I go against or opposite the arrow directions, my result will be negative. Remember, this is the symbol for cross or vector product. Now, first thing is when I have I cross j. Now watch. You're moving from I cross j. After this, where would it go to? To go to k. So it means that I cross j would be equal to k. I to j would lead you to k, right? Also, we do the same. We say j cross k. When you go j cross k, where will it lead us to? To lead us to what? To I. Now, also, we can say k cross I. I say k cross I. Where is it leading us to? It's leading us to j. Right? Now, this is a convention I've chosen to use, right? And if you follow it, your result would always be correct. Now, if we go the opposite way, say we do j cross I, because we are going against the normal direction. So if I say j cross I, this would lead me to what? K. But because we're going against, I would say it is minus k. So if I do the same and say I cross k. I'm going back, this would lead me to negative j. So if I say k cross j, I'm going back, this would lead me to negative I. So these are basic things you should know. And then additionally to this, it's important you know that when you now cross vectors in same direction, the result would be 0. That is to say, if I have I cross I, the result will be same as j cross j, same as k cross k, and this would be 0. So take note of this. This differs from dot product. So when you cross this in same direction, the result would be 0, right? Now, since we have learned this and we understand it, let's look at the types of vector products. We have two types, just like we saw in scalar. So number one is arithmetic product, and number two is geometric product. So in this video, I'm going to consider just arithmetic so that the video is not too long. In the next video, we're then going to dive into geometric cross product. Now, whenever you hear arithmetic, just the same way we studied under the scalar product, when you hear arithmetic product, arithmetic has to do with multiplication of the component of the vector. So that is what we want to consider arithmetic. Arithmetic, it deals with the components of the vector. So this is very important. Whether in cross product or in dot product, it considers what? The components of the vector, right? Now, the cross product, if you say you want to multiply with just freehand or just do it direct, it's going to be very long. So there is a special way for carrying out the arithmetic product, which is using the determinant method in matrices. I'll be explaining it in such a way that it will be very clear to you, even if you've never done matrices before. So watch. Now say we have A equals AXI AYJ plus AZ and then K. And then we'll have B equals BXI BYJ BZK. Say we have this. These are two vectors. I want to find A cross B. That is the cross product of A and B. We want to find this using determinant. First thing you want to do is to create your determinant symbol. This is a determinant symbol. Then the next is to arrange the unit vectors from I to J. So I have I have J, and I have K. I would arrange them, knowing that above I would always have plus. It doesn't change. Above J, I would always have minus. Above K, I would always have plus. It's an alternating sign, starting from plus, plus, minus, plus, right? Yes. The next thing, since your A is coming first, you arrange the components of A. What are the components of A? You have AX, which comes under I. So you have AX. It has to be A before B. If you arrange B before A, you will get a different answer. You get a negative of the answer. So you have to follow it A before B. So I have AX, I have AY, and then I have AZ. I have BX, I have BY, and I have BZ. So this is what you do. Once you arrange it, the next thing is to reduce that into a 2 by 2 matrix and then find the determinant. So I want to reduce that to a 2 by 2. So this is what you do. You close, first you write your I, you're starting with I, then let's build a 2 by 2 matrix. You close everything that has to do with I vertically and horizontally. So if you watch this place, I is connected to this place, so I don't want to see this place again. So watch as I'm closing it. Now if I close also this part, you would see that I'll be left with this, closing here and striking here. I'll have this. That is for I. So writing it, I have AY, AZ, I have BY, and I have BZ. Then the next, I'll go for J. Remember, J is carrying a minus, so I have minus J. So I have this. I'll strike everything that has to do with J vertically and horizontally. And this is J. If I strike this part, watch as I strike it. If I strike this part, and then I strike this part, you notice you can now see this. Watch, I repeat. I'll strike this part for J. I'll strike this part. What can you see? AX, AZ, BX, BZ. So I have AX, AZ, BX, BZ. This is what you have for J. And finally, you have for K plus K. Remember, your K is carrying a positive. That is why it is plus K. Now, I'll strike everything that is connected to K vertically and horizontally. So if I strike this part, then I strike this part, what can you see? AX, AY, BX, BY. I repeat, I'll strike this part connected to K. I'll also strike this. So I have this. So I have AX, AY, BX, BY. So I've reduced this to a 2 by 2 matrix. Then finally, which I may not do, okay, let me just do it. I have my I outside. Finally, this is how you multiply. This times this minus, immediately you multiply this, you introduce a minus. So this times this is going to be AY, BZ. I would introduce a minus immediately. Then I'll do this. This times this is going to be AZ, BY. Right? The same way I'm done with this part, I will go to the next one. This is J. I will go this way. This is AX, BZ. I would introduce a minus immediately. Then I'll go this way. This times this is AZ, BX. Right? I will close that. Then I'll go for K plus K. I'll do this. This is AX, BY. I'll immediately introduce a minus, then go the other way. This times this is AY, BX. And this is our answer. So for a practical problem, you would now see that you would get an answer that still includes I, J, and K. So let's take a quick example so that this concept will be clear to us. Let me draw the problem. Alright, very quickly we want to analyze this and draw the video to an end. Now we have A is this, B is this. Find A cross B. Find A cross B. So remember, the first thing we want to do is to put it in a matrix determinant form. So I'll draw my determinants, put what? I, J, and K. Remember, I should carry positive, negative, and positive. This is a constant sign that you should always arrange there. Now, since A is coming first, I will check for the components of A and arrange them under the I, J, and K accordingly. Now, for A, I have that the coefficient of I is 2. So I'll drop that under I. If you watch for A, you notice there is no J. J is missing. So it means I'll put 0 for J. Then K, the coefficient of K is -1. So I'll put -1. I'm done with A. The next thing is to look at B. The coefficient of I is 1. I'll put 1. The coefficient of J is what? 2. I'll put 2. And then you notice there is no K. K is missing. So I'll put 0 there. Now, since you've done this, want to then reduce this to a 2 by 2 matrix. So starting with I. So I have I. Now, if I cut out everything that connects to I, I'll cut this out. Cut this out. I can see 0, -1, 2, and 0. So 0, -1, 2, and 0. The next, I'll go to -J. So this is -J. So if I cut out everything connected to J, I'll cut it out like this. Watch my hand. Cut this. Then I'll cut this. You'll be seeing 2, -1, 1, and 0. 2, -1, 1, and 0. Then finally I have plus K. So I'll cut out everything that connects to K vertically. So if I cut this and I cut this, I can see 2, 0, 1, and 2. 2, 0, 1, and 2. Now, very quickly, I want to multiply out. So I have my I, open my bracket. I'll go this way first. It has to be this way first. So 0 times 0 is what? 0. Immediately I multiply this. What will I do? I will introduce my minus sign, right? Yes. Alright. And the noise increased. I had to pause the video. Now we have this times this is 0. Then you immediately introduce your negative sign. Then you have minus 1 times 2 is minus 2. When it comes here, it makes this minus to become plus 2. Right? Now let me repeat it for the sake of clearing confusion. Let me repeat that line so that you don't get confused. Now let's start again. I will do 0 times 0 first is 0. Immediately I multiply, I introduce minus. This minus is constant. Now watch. I'll go the other way. Minus 1 times 2 is what? Minus 2. When that minus 2 comes here, that minus would affect this minus and it becomes what? Plus. So I would say plus 2 now. Then I'm done with this side. I'll go to minus j, which is outside. Open my bracket. I'll go 2 times 0 is what? 0. Immediately I multiply this, I would introduce my minus. I will go again. Minus 1 times 1 would give me what? Minus 1. When it comes here, it would again affect this minus to become what? Plus 1. Then I will go again, finally, plus k. This part. So I would have 2 times 2 is what? 4. Immediately I multiply, I would introduce minus. Then 0 times 1 is 0. Right? So that very quickly I can have this. So I have 0 plus 2 is 2. 2 times I is 2i. I'll go the next one. 0 plus 1 is 1. And then 1 times minus j is minus j. I'll go again. 4 minus 0 is 4. 4 times k is plus 4k. And this is what I have as A cross B. You can see that my answer carries I, it carries j, it carries k, which is another vector. So it means that A cross B would give rise to a vector. Now this would bring me to deduct some points I want you to note, and then that is the end of this video. So points to note. Number 1 is that cross product is not commutative. Is not what? Commutative. Rather, it is anti-commutative. So rather than saying it is commutative, you say it is what? Anti-commutative. What does it mean? It means that A cross B is not the same as B cross A. So assuming A cross B would give the same result as B cross A, then you say it is commutative. So, but A cross B would not give the same result as B cross A. Rather, what you would have is that A cross B would give you the negative of B cross A. So this property is what you call anti-commutativity. So this is what you call anti-commutativity, right? So that is one point that should be clear to you. Now, secondly, is that cross product A cross B gives a vector. A cross B would always give you a what? Vector. Unlike what we learned in scalar, A dot B for scalar gives a scalar. But A cross B gives a what? A vector. So these are important points for us to note. Remember, what we have just studied in this video is arithmetic vector product. We are yet to consider the geometric vector product. So, but for the sake of time, I'm going to stop this here. If you have watched this video till the end, you do well to hit the subscribe button so that when I post the next one, you'll be among the first to be notified. like this video, comment on the video, and then share with 10 of your friends. Tell them it is prime concept. I'll see you in my next video where we shall be analyzing geometric cross product, and I'll be giving you important tips for your exams, your JAMB exams, your WAEC exams, your JUPEB exams, your University 100 level exams, and so on. Thanks for watching Prime Concept.